Alright, in this video we're going to look at solving quadratics using the zero product property. So we're going to take an idea that we're familiar with, zero product property, which tells us if the product of multiple factors is equal to 0, one of those factors has to be 0. So we're going to take that idea and now we're going to combine it with our quadratics and what we've done with some factoring. So first let's start out with the word solutions. The solutions to the quadratic equation are where it is equal to 0. So this means what we identify as solutions, we're always going to set our quadratic equation equal to 0. And the values that make that happen are going to be known as solutions. There's a couple other names we use synonymous with solutions. We can call these values roots, zeros, or x-intercepts. And we'll kind of get into that a little further, but first let's identify how to find them. So let's go first to A. So A should look familiar. It's our quadratic when it's already factored. So this is what we've had a huge emphasis and focus on in the last couple of days, was how do I get this factored form from my quadratic? The difference here is instead of a quadratic expression, we now have a quadratic equation. It's an equation because it's equal to a value. In this case, it's 0. Going back to the top, the solutions to the quadratic equation are where it is equal to 0. So that's always what we need. We always want this equaling 0. All right, so now it's like we've seen before. So if this is a factor and this is a factor, they multiply to make the product of 0. That tells us both factors, or not both, but one of the factors must be 0. So we're going to go ahead and find out when is x plus 3 equal to 0. And then when is x minus 2 equal to 0. So nothing real new here in regards to this zero product property. Here my x would be negative 3, and here my x would be positive 2. So these two values are the solutions to the equation. So just a quick note that these are the solutions. Could call them roots, could call them zeros, could call them the x-intercept. Looking at B, again, we're already factored. So we're not doing that process on our own. So I'm going to find out when does D minus 5 equal 0, and when does 3D plus 4 equal 0. Solving here, we know that D equals 5, and on the right side, we would subtract the 4 and then divide by the 3, giving us a solution of negative 4 thirds. C and D need to factor. So here I have a quadratic expression equal to 0, making the quadratic equation. So looking here, I have an a value of 1 in my ax squared plus bx plus c form. So I can use my shortcut and think what multiplies to 3 and adds to negative 4. It's going to be negative 3 and negative 1. So it's going to be x minus 3, x minus 1 equals 0. Don't forget to bring the equals 0 down. Alright, so I want to know when does x minus 3 equal 0 and when does x minus 1 equals 0. Mental math tells us x equals 3 and x equals 1. And those will be my two solutions to that quadratic equation. Alright, looking at D, again, not factored like before, so we have to do that on our own. I don't have an a value of 1, so I'm going to go generic rectangle. I'm also going to check and make sure I can't factor out a GCF. There's nothing I can take out of all three terms, so that's not going to be an option. Bottom left, 8x squared. Top right, negative 3. This tells me I need to multiply to negative 24x squared, and I need to add to 2x. That's going to give me 6x and negative 4x. Once I have my generic rectangle filled in, find my dimensions. So I'm going to factor out a 4 here, a 4 and an x going this way, leaving me with a 2x here, a negative 1 here, and a 3 here. So now my factored form is 2x minus 1, 4x plus 3, and I need that to equal 0. So again, I'm just rewriting what I had at the original, but in factored form rather than standard form. All right, I need both terms to equal 0, or find out when both terms would equal 0. So 2x minus 1 equals 0, 4x plus 3 equals 0. Solving here, x equals 1/2. First solution. Solving here, x equals negative 3/4. Second solution. All right, then moving on to the last the last two. This is where I have a quadratic equation that's not equal to 0. So what I need to do is first move the variable so it is, then I'll factor, then I'll find my zeros or my solutions. So get rid of this 7 here to make this side 0. So subtract 7, x squared plus 6x minus 7 equals 0. All right, so I'm equaling to 0. Now I can solve. Factoring, a is 1. This is going to factor to x plus 7, x minus 1 equals 0. And then some mental math will tell me that x equals negative 7 and x equals 1. And those would be my two solutions using the zero product property. And our last one, which will probably take the longest, 12x squared plus 3x equals 2 minus 2x. I'm going to move both of these terms so this side equals 0. So what I need to do is subtract 2 and add 2x. Subtract 2 and add 2x. That's going to leave me with 12x squared. 3x plus 2x is 5x. And then the negative 2 by itself. Thus equaling 0 on the right side. Now I need to use a generic well, first I'll check, do I have something I can factor out of each term? That answer is no. So now I'm going generic rectangle. 12x squared and negative 2. I need to multiply to negative 24x squared. All right, looking across here, I'm going to go this way. I can pull out a 3 and an x. Building off of that, this is 4x, this is negative 1, and this is 2. Giving me the factored form of 4x minus 1 times 3x plus 2 to 0. Now I'm going to go ahead and solve both of these. So I have here 4x minus 1 equals 0. It's going to give me an x value of 1 over 4, first solution. And then here, 3x plus 2 equals 0. Subtract the 2, divide by 3x equals negative 2/3. And that is how I can solve a quadratic equation. So just to recap, got a couple stages here. If they're already in factored form, set them both equal to 0. If they're not and we need to factor, find the factored form ourselves, set equal to 0, and solve. And E and F, not even equal to 0 yet, so get them equal to 0, then factor, then solve. And again, we're finding the solutions of a quadratic equation.